Hey everybody, we are talking about some more factoring today. The difference is today is we're going to be doing quadratic, right? That means anything with a highest exponent of 2. Trinomial, which is 1, 2, 3 terms. But this time it's when a is not equal to 1, but when a is greater than 1. So to start this, we're going to go ahead and jump onto our factoring graphic organizer. We're going back to it, and it's on the back of section, the 1.3 notes from last time. So let's go back over there. Let me find where I put it. Here it is. So this is where we kind of left off on our factoring graphic organizer. We did 2 terms, we did 3 terms when a equals 1, and before we do 3 terms where a is greater than 1, we're going to go ahead and jump onto 4 terms, which means that we're going to factor by grouping. So for this one, remember, we always check for the GCF first. When you pull out a GCF, then you're going to count the number of terms. So sometimes the terms, there are 4 different terms. And if there's 4 different terms, we're going to use grouping. Okay? So when we use grouping, so for example, if we have 3x squared plus 6x plus 4x plus 8. The first thing that we're going to do with grouping is we're literally going to group the first 2 and the last 2 terms together. Once we do that, we're looking for the GCF of just this part. So what I want you to do is kind of ignore the second parentheses group. So I'm going to kind of zoom in so you can ignore it. You can cover it up with your finger, however you want. But let's see what the GCF is of both of these terms. Well, I can see that, let's just look at the coefficients, 3 and 6. I know that both 3 and 6 can be divided by 3. So I'm going to pull out the 3. I also know that x squared and x can be divided by x. So I've got 3x is the GCF of that one. And then what happens here is now I have to figure out what multiplies back to get to 3x squared. So I know 3x times x gives me 3x squared. I'm going to bring down the plus sign. And then I'm going to figure out, okay, 3x times what gives me 6x. Well, I know 3x times 2 would give me 6x. Okay, and that's what I do there. Then I'm gonna kind of zoom in on the other side, and I'm gonna look for a GCF of this side as well. So I'm also going to be looking for the GCF here as well. So I know I'm going to zoom in here. Looking for my GCF, I can see I know 4x and 8 both can be divided by a 4. And if I can divide both of them by 4, I'm also going to bring down this plus sign right here, by the way. I know 4 times x will get me back to 4x. I'm going to bring down the plus sign. And then I know that 4 times 2 will give me 8. So 4 times 2 gives me back to 8. Now here's the thing. If I scroll, check this out. You guys, congratulations. We've got twins. Woohoo! So when we've got twins, now we're going to do, basically those twins are going to become the GCF of what we're talking about here. So we're going to take the GCF of our twins. So our twins right here and right here, x plus 2, are both going to come out to right here. So we're basically saying, okay, this is the greatest common factor of the first part. This is the greatest common factor of the second part, and we're pulling that out. Then in the second parentheses is going to go everything else that we've got left out. So this is going to get placed right here, 3x, and this plus 4 is going to get placed right here. And that is how we factor using grouping, okay? So the first thing is we're going to group the first 2 terms and then the second 2 terms. You're going to find the GCF of each group. And then the hope is that we find twins. Once you find the twins, those become the GCF of all. Okay, and then you finish by factoring. Okay, so now that we know how to group, or do we know how to factor by grouping, let's talk about how do we do a 3-term trinomial. So in a 3-term trinomial, which is right here, 3 terms when a is greater than 1. So we cannot use a equals 1 like we've been using. So that means there's something like when we've got, ax squared plus bx plus c. When this a is something other than 1, this is what we're going to use. So what we're going to use here is something not x factor, but we call this x grouping or x group. So when it's 3 terms, a equals 1, we use x factor. But when we use a is greater than 1, we call that x grouping. And so what we're going to do first is we're still going to set up that big x. So let's say, for example, you've got 5x squared minus 17x plus 6. And we need to factor this. Remember that this is still in standard form. Whoops. We've got a, b, and c. So on our x, our big x that we put here, instead of c on the top, we're going to put a times c on the top. And we're still going to put b on the bottom. So let's look at here. If I've got a is 5 and c is 6, a times c gives me 30. And then our b value is still negative 17, just like it was the way we did it before. So now I have to figure out here what's going to add to 30, or excuse me, what's going to multiply to 30 and add to negative 17. Well, let's look at some of those numbers. I know 1 and 30 cannot make a 17. How about 2 and 15? Let's check. So I know 2 and 15 can multiply to 30, but can 2 and 15 add to negative 17? Well, no, they can't right now, but what if we made both of them negative? Let's try again. Can these multiply to a positive 30? Yes. Does negative 2 and negative 15 add to negative 17? Yes. Okay, perfect. So now we have those numbers that basically will make up a negative 17 that we have here. So this is when the second part to that process goes. So we just did the x, and now we're going to do the group. So here's how the grouping comes in. I'm going to take these two numbers here, and I'm splitting the b term up. This b term of negative 17x, I'm just going to rewrite this. Well, isn't that the same thing as negative 2x and negative 15x? Aren't those equivalent? Okay. Then we're going to just bring down what the c value was, which is plus 6, and the ax squared, which was 5x squared. So do you see how now that I'm looking at this, you don't have to erase it, but I'm going to kind of erase mine just to clean this up a little bit so you can see. So doesn't this look like that 4 term over here that we had when we used grouping? So now we're going to use the grouping process. So remember, this is x group. So we split up that middle term into 2 pieces so that now we can use grouping. Okay, so we're going to write grouping. Just like we did with those 4 terms. Remember, the first part of grouping is we group the first 2. If there's a minus sign like there is here, just put a plus in front. It doesn't change the value, but it's an important placeholder. And then we're going to group the last 2. Our next part of grouping, just like on your graphic organizer, is now we're going to look for the GCF of this first part of that group. So let's look for that GCF. So 5x squared and 2x, the only thing they have in common is an x. So I know x times 5x will give me back 5x squared. I'm going to bring down the minus sign. And then x times 2 will get me back to the 2x here. I'm going to bring down this plus sign right here. And now I'm going to look for the GCF again for this group here. So I'm looking at negative 15 and 6. I know I can pull out a negative 3. And what that's going to do for me, remember my goal is twins. And so I want whatever's inside these parentheses to look the same as this. So if I pull out a -3, that will allow my -15 to become a +5, which is what I have here. That's what I want. So -3 times +5x will give me back to -15. Bring down the plus. And then I'm going to go, okay, well, I know -3 times +2 will get me back to that +6. Ooh, pardon. No, it's not. I need this to be a negative. There we go. So now I know -3 times -2 is +6. So remember, at this point, now we're looking at, okay, oh, look, congratulations. We've got twins. When we've got our twins, those are the GCF of everything. So we're pulling out the twins, 5x minus 2, and we bring down everything we have left. So we've got x and our plus a -3. Well, plus a -3 is just a -3, and that is how we factor. This is the hardest type of factoring, so if this doesn't click for you right now, that's okay. We're going to get some practice with it, and then we'll keep going, okay? So fill that out on your graphic organizer, okay? And then let's go ahead and list off what we do first. So first one is we're going to do our X box, where we put A times C at the top, B on the bottom. Figure out the two terms that will multiply to A times C and add to B. Then you're going to split the middle term into whatever these numbers were here. So we're going to split the B term. So instead of ax squared plus bx plus c, that middle term is going to split into, so let's call this m and n. Then this becomes m and n x. So we split up that b term into the values of m plus n. And then we've got our ax squared and c. And then you go ahead with your grouping and you treat this as a 4 term. All right, let's go back to our notes. Okay, so let's say, for example, we don't have a 4 term, okay, just like we did before. We don't have a trinomial. What if we have a special 2-term quadratic? So look at your graphic organizer. I know is there a GCF here? We're going to look for it, and yes, there is. I see that they both can be divided by a 5. So I'm going to pull out a 5, and I'm left with x squared minus 9. Now inside here is what I have left to factor. So those are 2 terms. So on your graphic organizer, look at your 2 terms, and we have to check to see, okay, is it dots? DOT stands for difference of 2 squares. We know x squared is a perfect square, and so is 9. So this becomes x, and x is x squared. 3 times 3 is 9. 1's a plus, 1's a minus. And then just bring down this 5. And that would be how we factor something with a GCF. The other thing is, what if we have 2 terms, but there's a special pattern? Just remember, is there a GCF? 9 and 64, although we want them to divide out, they can't. So then we're going to look at our 2 terms. Again, remember, 2 terms means we look to see, is it difference of 2 squares? Let's look. There's definitely a minus. Is 64 a perfect square? The answer is yes. It's 8 times 8. Is 9x squared a perfect square? The answer is yeah. It's like saying 3x times itself. So what we're going to do here is we're going to split this up into a dot. So we know 3x times itself is 9x squared. So 3x goes here in the front. And then we've got 64 is really 8 times itself. So we put 8 and 8 here. 1 is a plus and 1 is a minus. And then we're done. All right, the last thing we're going to remember we talked about, just like we have different words for cool, we have different words for x-intercepts. It could be zeros, solutions, or roots. And the vertex of all of these is in the exact middle of the x-intercepts. So if P and Q are the x-intercepts, then the x value of the vertex is P plus Q over 2. We talked about that a little bit, but we're going to use that more as we move on. Thanks for joining me. I'll see you next time.